Okay. Last time we have discussed about how to derive an equation using given physical quantities. Okay. In this case, we have some homework to discuss. Okay. Okay. We have discussed up to question number 5, no? Anyone? Yeah, okay. Okay, question number 6. The period of oscillations, T of mass M, which is a helical spin proportional to the spin constant K, and mass M, proportional constant is 2.5. Okay. Okay. In this case, we are given some data. The time period, the period of oscillation of a helical speed depends on the mass attached to it and spring constant. Suppose there is a spin and M mass is attached to that spin. Suppose there's a spin and say capital M mass is attached to that spin. We can give some displacement. We can give some displacement to this mass and release. After releasing, what will happen is, after releasing, this mass will be oscillated. Okay. The time taken for one oscillation, is the period of time. That is the meaning of period of time. Okay. According to the given data, that period of time, period of oscillation depends on this mass and the spring constant. This mass and the spring constant. Those are the data given in this question, and we can take the proportional constant as 2.5. Okay. Now, my objective is determine or build in an equation using these physical quantities. So my first step is the assumption. I will assume the period of oscillation directly proportional to some power of M. That is my assumption. And I will assume the period of oscillation directly proportional to some power of K. K means spring constant. Okay. Then I can combine these two. As a product of them So period of oscillation directly proportional to the product of these two physical quantities. So this is a relationship. Using this relationship, I can convert this relationship into an equation. As this is a directly proportional relationship, I can replace this proportionality symbol using equal and constant. Don't use K because here K is there. I will use C as the proportionality constant. M to the power X, K to the power Y. C is the proportionality constant. Proportionality constant. Okay. Okay. Now, according to my assumption, I have derived some assumed equation. In this equation, there are some unknown terms. What are those? C, X, and Y. If I can find those values, then I can determine the equation between these physical quantities. C value is given. We can take it as 2, 5. C value is given. It is a constant. So now I want to find X and Y only. X and Y only. How to find that one? I can use dimensional analysis to find X and Y. So as this is an equation, both sides should have same dimension because it is an equation. As is an equation, both sides should have same dimension. So dimension of LHS should be equal to dimension of RHS. Dimensions of RHS. LHS here, capital T. Dimension of capital T should be equal to the dimension of M to the power X, K to the power Y. I don't want to write C because C has a numerical constant. C is a numerical constant. So it doesn't have a dimension. So I don't want to write this one. So dimension of T should be equal to the product of dimension of M to the power X, dimension of K to the power Y. Okay. Then dimension of T. T means time, no? In this case, T is period of oscillation. Period of oscillation means it is a time, Puta. So dimension of T is equal to T. Dimension of M. M is a mass. So dimension of M is M. Dimension of K. Dimension of K. So what is the dimension of K? Spring constant. Can anyone tell me? What is the dimension of K? Spring constant. Dimensions of spring constant? Yes. MT minus 2. MT minus 2. MT minus 2 to the power Y. After that, I can simplify this one. So T is equal M to the power X, here M to the power Y. Both are multiply each other. So the power of them will be added. The powers of them will be added. Then there's T term, T to the power minus 2 into Y. Minus 2 into Y means minus 2Y. Here, again, this is an equation. So both sides should have same terms. So the powers of same bases. Powers of same bases should be equal. So I can equate powers of same bases. I can equate powers of same bases. So if I equate power of t, LHS, in LHS power of t is 1, RHS power of t is minus 2. Minus 2y, minus 2y, minus 2y. So from that, I can derive y is equal minus half, minus half. Then I can equate power of m, power of m. In LHS there's no any m term, so power of m in LHS is 0, is equal to 0. But RHS, the power of m is equal x plus y, x plus y. I know the power, I know the value of y, it is half, so minus half. If I replace that value here, I can determine the value of x, it is equal to half. It is equal to half. Okay. So x is equal to half, y is equal to minus half. And I know the value of c. This is my assumed equation. This is my assumed equation. Here, now I know all the unknown terms. No, I have determined the value of x. I have determined the value of y, and I'm given the value of c. Okay, so all the unknown factors are known now. I can substitute those values in this equation. If I substitute those values in this equation, t is equal c is 25 m to the power half k to the power minus half, k to the power minus half. Okay. Then I can write this one as 25 m over k entire half. So t is equal to 5 within square root m over k. M over k. Okay, everyone. Do you understand how I did this calculation? Everyone. I know. I want your response. Good. Others? Good, good. Okay. If you need any changes to be done, please do that. This is question number 6. Question number 6. This is question number 6. Okay. Question number 7. The distance s traveled by a freely fallen object is proportional to the time t and gravitational acceleration g. Proportional constant is half. Okay. Shall I erase this one now?
1 second.
Okay. Have you done in this May as a homework or not?
Yes, sir. The last bit I had to write.
Okay.
Yes, sir. Okay, sir. Done.
Okay. What about next question? I will share that one. Seventh one. Okay. If anyone want to try this one, I will give 2 minutes. Okay. Seventh one. Okay. This is the data given in the question. Freely fallen object means if I drop a object, something like this, it is called as freely fallen objects because its initial velocity is 0. If the initial velocity of an object is 0, we can call it as freely fallen object. So the distance, the travel distance of a freely fallen object depends on gravitational acceleration and time, and we can take the proportionally constant as half. Okay, so we can do our basis. The first step is assumption. First step is assumption. I can assume the distance, the travel distance is directly proportional to some power of g. Some power of g. That is an assumption. Okay. Then again, I can assume the travel distance directly proportional to some power of y. So After that, I can combine these two relationships. So if any physical quantity is directly proportional to more than two physical quantities separately, I can write it as a product. This physical quantity is directly proportional to the product of other physical quantities. This is my relationship. This is my relationship. So this is my assumed relationship. After that, I can convert this relationship into an equation. I can replace this proportionality mark from equal and constant mark. So S is equal constant into G to the power X, T to the power Y. K is the proportionally constant. K is the proportionally constant. Again, K is the proportionality constant. I can take it as half. Okay. So this is my assumed equation, Kuta. This is my assumed equation. Okay, this is my assumed equation. In this equation, I have three unknown terms. What are those? K, X, and Y. K is already given. So I want to find X and Y here. X and Y here. To find X and Y, I can use dimensional analysis. As this is an equation, LHS and RHS should have same physical quantity. So the dimension of LHS should be equal to the dimension of RHS, as this is an equation. You have to write each and every logic, okay? I'm not going to write here, but you have to write this one. Because this is an equation, LHS and RHS should have same physical quantities. So the dimension of LHS should be equal to the dimension of RHS. Okay. Okay. Again, dimension of LHS means dimension of S. Dimension of RHS means dimension of G to the power X into T to the power Y. T to the power Y. Dimension of S. S means distance. Distance means it is a length. So dimension of S is equal to a length. That means L. Dimension of G. G is gravitational acceleration. So it is an acceleration. So dimension of G is equal LT minus 2 to the power X. Dimension of T means time. T to the power Y. Then I can simplify this one. L is equal L to the power X. There is only one L term. Then there are two T's. One is minus 2 into X. Minus 2 into X means minus 2X plus Y. T to the power minus 2X plus Y. This is the simplified equation. After simplifying this equation, I can equate the powers of same bases. I can equate the power of same bases. Because this is an equation, both sides should have same terms. Okay. Okay, once I equate powers of L, if I equate power of L, LHS, the power of L is equal to 1. RHS, the power of L is equal to X. So X equal to 1. X equal to 1. Then I can equate power of T. Power of T. LHS, there is no T term. So the power of T is equal to 0 in LHS. The power of T in RHS is equal to minus 2X plus Y. Minus 2X plus y. Okay. I know x is equal to 1. If I put 1 here, y is equal to 2. Y is equal to. So this is not the answer. This is not the answer. Finding x and y is not the answer because I want to determine an equation. So this is not the answer. Don't stop here. Don't stop here. Because finding x and y is not our objective. So once I found these two values, I can substitute those two values into this assume equation, and I can determine, or I can build an equation between the given physical quantities. So S is equal. Now I can substitute value k is half, g to the power x is 1, t to the power y is 2. This is my equation. This is my equation. Okay, everyone, do you get my point? Have another? Good. කරපොය ආන්සර් කාවද මේ ආන්සර් කාවද කරපොය Okay, once you finish writing, you can try question number 8 and question number 9. Question number 8 and question number 9. I will give you 5 minutes. Okay, question number 8 and question number 9. Okay, try කරන්න පුතේ කට්ටියම. Question number 8 and question number 9. After finish writing this one, you can try question number 8 and question number 9. Okay. Once you finish question number 8 and question number 9, please take a photo and may send that to me. Okay. Question number 8 එකයි 9 එක කරලා ඉවර කට්ටිය ෆොටෝ එකක් අරගෙන මට ටග් ගාලා send කරන්න බලන්න හරිද කියලා බලන්න. Okay. Have you done question number 8 and question number 9? Okay. I will give 2 minutes. Okay. Shall we do question number 8 first? Okay. Work done. Work done. Work done by a gas depends on the pressure and the volume change. The work done of a gas depends on the pressure and the volume change of the gas. Okay, this is the data we have. So, and the proportional constant is 1. Using those data, using those information, I need to determine, or I need to derive an equation between these physical quantities. Okay. As I explained earlier, my first step is the assumption. Okay. Assumption is the work done, W, is directly proportional to some power of P. Some power of P. This is assumption. I don't know whether it is 1 or 2 or half or minus 1. No, I don't know that one. Okay. I can determine that one after that. But the first thing is assumption. Assumption means I have assumed work done is directly proportional to some power of pressure. Then my second assumption is work done is directly proportional to some power of y. So I can combine these two relationships and build this one. P to the power x, v to the power y. Using this combined relationship, I can derive an equation. I can convert this one into an equation. You have to write this one. You have to write this one. You have to write this conversion thing. So I can convert this relationship into an equation. Once I convert this relationship into an equation, I will have W is equal constant into P to the power X and V to the power Y. I have converted that thing. Okay. K is proportional constant. You have to mention that part. K is proportional constant. Because, as I told you earlier, if any two physical quantities are directly proportional, the ratio between them is a constant. According to the definition, I can convert this relationship into an equation because these two physical quantities are directly proportional. According to my assumptions, these two, W and P to the power X into V to the power Y, this whole term, W and this whole term are directly proportional. So, if those two terms are directly proportional, the ratio between them is a constant. So, ratio between them is a constant. So, using this definition, I can convert this into an equation. So, this is my assumed equation, Putta. This is my assumed equation. Here, there are three unknown terms. What are those? Proportionality constant K, X, and Y. K is given. So, my objective is, my calculation is determining these two unknown factors, X and Y. To determine X and Y, I can use dimensional analysis. As this is an equation, both sides, LHS and RHS, would have same dimension. So, LHS, dimension of LHS should be equal to dimension of RHS. You have to write the logic. What is the logic? As this is an equation, because this is an equation. Okay. Then you can apply this dimensional formula here. So dimension of W should be equal to dimension of P to the power X, dimension of V to the power Y, V to the power Y. W means work done, work done. Dimension of work done is equal to M L squared T minus 2. ML squared T minus 2. That is dimension of work done. Work done means work. Work is equal to force into displacement. Force into displacement. Force is MLT minus 2. So into displacement means L. So ML squared T minus 2. Pressure. Dimension of pressure. That is equal to M L minus 1 T minus 2 to the power X. Then dimension of V means volume, volume is L to the power 3. So L to the power 3y. L to the power 3y. After that, I can simplify this one. After that, I can simplify this one. LHS, you don't want to simplify anything here. ML squared T minus 2 is equal. Here, there's only one M here. M to the power X. M to the power X. So here M to the power X. Then there are two L's. L to the power minus X plus L to the power 3y. L to the power 3y. So L to the power minus X plus 3y. That means 3y minus X. 3y minus X. 3y minus X. Then T terms. T to the power minus 2 into 2 into X. T to the power minus 2 into X. That means T to the power minus 2x. Minus 2x. Okay. When there's power of power, when there's power of power, two powers are multiplied. Okay. Then I have simplified this equation. Then I can equate powers of same bases. I can equate powers of same bases. I think the easiest one is sorry. Easiest one is M, no? Equating powers of same bases. As this is an equation, powers of same bases should be equal in both sides. Okay. So M. LHS power of M is 1. RHS power of M is X. So X is equal to 1. Then if you want to find Y, you have to equate power of L. You have to equate power of L. In here, power of L is 2 LHS. Right hand side, power of L is 3y minus 1 minus X. 3y minus X. Then you can substitute value of X here. Substitute value of X here. X is equal to 1. So this is minus 1. You can bring this minus 1 to LHS. So it will be plus 3. Plus 3. So 3 equal 3y. That means y equal 1. Y equal 1. So X equal 1 and y equal 1. K is also equal 1. So I can substitute those three values in equation 1. I can substitute those three values in equation 1. Then I will have this equation. W is equal, K is equal 1, X is equal 1, Y is equal 1. So it is equal, W is equal PV. PV. Okay. Did you understand? Okay. If anyone need any further clarification, I will give that one. Okay. Okay. Let's do question number 9. Question number 9. In question number 9, there is some calculation. Question number 9. Everyone. The volume rate Q of a viscous fluid flowing through a horizontal capillary tube depends on the following factors. Okay. Volume rate. What is the meaning of volume rate? Rate of in here there is a word. In here there is a word rate. The volume rate Q. Volume rate. So what is the meaning of that term? Volume rate and the volume is two different things. Volume rate. Can anyone tell me what is the meaning of rate? Volume rate. Otherwise you cannot do this question. Volume rate. Volume rate කියලා මොකක්ද? Rate කියන්නේ මොකක්ද? Rate. So what is the meaning of rate? Rate. Rate. I think you have defined velocity in your hours. You have defined velocity. How to define velocity, Puta? How to define velocity?
Displacement per unit time.
Displacement per unit time, or otherwise I can define it as the rate of change in displacement. The rate of change in displacement. So that is equal to the rate displacement change in unit time. Displacement change in unit time equal to the rate of change in displacement. Rate means it is equal to, actually it is a per unit time. That means if there is any work, if there is any change in physical quantity in a unit time, it is called as rate of change in that physical quantity. So if the if displacement is changing, is being changed during some time period, I can define the rate of change in displacement as the displacement change divided by time. Okay. Rate of change means it is a speed. Rate means speed. It is a speed. If you want to measure a speed, definitely you have to consider the time. You have to consider time, Putta. Okay. Rate means actually it is some kind of speed. So if you want to measure rate, then definitely you have to consider time. Okay. Therefore, rate, we are given volume rate, Putta. Volume rate. The volume rate of a viscous fluid. Volume rate means volume per unit time. Volume per unit time. Rate means per unit time. Rate is equal per unit time. Rate. That is the meaning of rate. Rate means per unit time. Okay. Unit time එකකදී කියන එක තමයි යාගේ meaning එක. ඒ කියන්නේ unit time එකකට volume change එක තමයි බලන්න ඕනේ volume එක. හරි. That means if there is a horizontal capillary tube, if there is a horizontal capillary tube here and some viscous fluid is flowing through this tube, suppose some viscous fluid is being flowing through this tube. The rate of flow, the rate of volume is volume discharge per unit time. Volume discharge per unit time through this tube. Okay. The rate of volume is volume discharge per unit time. Volume discharge per unit time. So that is equal V over T. V means volume, time is T. So Q is equal, in here Q is equal V over T. Q is equal V over T. Okay. දැන් හදන්න බලන්න. කට්ටිය. හරි බලමු අපි. The volume rate depends on radius, pressure gradient, coefficient of viscosity. Okay. That's mean, suppose there's a capillary tube. There's a capillary tube, horizontal capillary tube. Suppose there is a fluid flowing through this capillary tube. Okay. The rate of volume flowing through these capillary tubes, the rate of volume Q is equal to V over T, depends on radius and pressure gradient, L is length, okay, L is length, delta P means pressure difference, and the viscosity, coefficient of viscosity. The dimension of coefficient of viscosity is given, okay. Now we have to build an equation between these physical quantities. V over T volume rate depends on these factors. Okay. Maybe you don't know about this one because this is a viscosity phenomena. But you know all these physical quantities. Then you can build an equation. Okay. You know about volume, you know about time, you know about radius, you know about pressure, length, and maybe you don't know about this one, but it is given. So all the physical quantities in these relationships are known. Okay. Therefore, you can try to find a equation. Okay. Okay. Let's do the basic. My first step is assumption V over T volume rate depends on some power of x, some power of r, some power of y. I can assume volume rate directly proportional to some power of r. Then my next assumption is this one directly proportional to some power of pressure gradient. And my third assumption is this one directly proportional to some power of eta. Then I can combine these these three relationships. Once I combine these three relationships, I can write V over T directly proportional to r to the power x, pressure gradient to the power y, eta to the power z. Then I can write the assumed equation using proportionality constant. So V over T is equal constant into r to the power x delta P over L to the power y eta to the power z. Okay. Then as this is an equation, then I can equate dimensions of RHS and LHS. So equating dimension of LHS and RHS, I can write dimension of V over T is equal dimension of r to the power x, dimension of delta p over L to the power y, eta to the power z. This symbol, this triangle symbol, okay? This symbol is a triangle symbol. It is called as delta. Delta. Normally we use delta to represent a difference. A difference. Delta P means pressure difference. Delta P means pressure difference. Difference. Normally we use delta symbol to represent difference. Represent difference. Delta. To represent a difference. Okay. Delta use karanne. Okay. Then I can replace dimension of each and every physical quantity in this dimensional equation. Okay. If I replace those dimensions, V over T, V over T means volume over T, volume over T, volume means L to the power 3, this one T. Then radius is a length, so this dimension of radius is equal to L, so L to the power X. Pressure difference over length, pressure difference over length, the dimension of pressure is M L minus 1 T minus 2 over L to the power Y. And dimension of eta is given, it is equal to ML minus T minus 1. ML minus 1 T minus 1. ML minus 1 T minus 1 to the power is it. To the power is it. මේක තමයි පොඩ්ඩක් සුළු කිරීමක් තියෙන්නේ. හරි බලමු. So now I have to simplify this one. If I simplify LHS, it become L T minus 1 is equal L to the power X. එකපාර කරන්නත් පුළුවන් මම එකපාරක් ලියන්න නැත්නම් තේරෙන්නේ නැති. M in here in denominator there is a L to the power plus 1. L to the power plus 1. I have to bring this one into the numerator. Once I bring that L into the numerator, the power will be minus 1. Power will be minus 1. So minus 1 means minus 2. Minus 2. So L to the power minus 2 here. T to the power minus 2 here into Y. M L minus 1 T minus 2 to the power is it. Then I can simplify this one. L to the power X. L to the power X here. X then here minus 2 into Y. Minus 2 into Y. Minus 2 into Y. Here minus 1 into Z. Minus 1 into Z means minus Z. minus is 8. Then m. Here m to the power y, m to the power y, m to the power y here, m to the power y here. Here m to the power is 8. So y plus is 8, y plus is 8 here. Then t. Here t to the power minus 2, t to the power minus 2y, t to the power minus 2 is 8, 2 is 8 here. T to the power minus 2 is 8 here. දැන් මොකද කරන්නේ? Here LT minus 2, L is L cube T minus 1, L cube T minus 1 here. Nothing to do. You have to equate. You have to equate both. You have to equate powers of equal bases. You have to equate powers of equal bases. I think it is easy to equate powers of m and power of t. Power of m and power of t contain only y and z. Only y and z. Only y and z. So if you want to find y and z, you have to have two simultaneous equations. If I equate the power of m, in LHS there is no m, so power of m is 0. In RHS, power of m is y plus z. Y plus z. So y plus z is equal to 0. Then power of t. In here, power of t is minus 1, Puta. Power of t is minus 1. The RHS power of t is minus 2y minus 2z. Minus 2y minus 2z. So all are minus, so I can multiply RHS and LHS by minus 1. So it becomes 2y plus 2z is equal to 1. 2y plus 2z is equal to 1. 2y plus 2z equal to 1. 2y plus 2z is equal to 1. Then මොකද වෙන්නේ? Okay, you can wait a minute. There should be some m L minus 1 T minus 2. Sorry, there's no 2y, okay? There's y, okay? Small mistake here. Minus 1 here, minus 1. So there is only z. There's only z, okay? There's only z. මෙන්න මෙතන පොඩි mistake එකක් මෙතන minus 1 තියෙන්නේ. මෙතන minus 1 තියෙන්න ඕනි. මම මෙතන minus 2 දාලා. හරි. Okay. මේක ලියා ගන්න මට එතනින් එහාට හදා ගන්න ඕන. Shall I erase this one? In here there are two equation. One is y plus z is equal 0. This is number one. Other one is 2y minus z. 2y minus z is equal to minus 1. Okay. Minus 2y minus z is equal to minus 1. If you want, you can multiply both side by minus 1 and if you want. Otherwise, you can keep this thing and do the calculation. Then these are two simultaneous equations. You can add these two equations, then z will be cancelled out. Then z will be cancelled out. Z will be cancelled out. Then minus plus y minus 2y means minus y is equal to minus 1. That means y is equal to 1. Y is equal to 1. If y is equal to 1, you can substitute that one in equation 1. You can substitute this value in equation 1. Then z is equal to minus 1. Z is equal to minus 1. Then find the value of r, find the value of x. Okay, I have simplified this one up to this level. After that, you can equate the powers of L here, In LHS, power of L is 3, RHS power of L is this one. Find the value of x. So I can equate power of L now. In LHS, power of L is 3 puta. RHS, power of L is this one. X minus 2y minus z. Now you can substitute this value here. If I substitute this value here, x minus 2 into y means plus 1. So 2. Then minus 1 means plus 1. Because z is minus 1. Minus 1 means plus 1. Is equal to 3. So x is equal to 4 then. Because minus 2 plus 1 means minus 1. You can bring that minus 1 to LHS, then x is 4. Okay, now you have the answer. Eh? You can substitute those values in this assumed equation. We have given, actually we are given the value of k. V over t means q. Don't write V over t yet now. Q is equal 5 over 8 into r to the power x delta p over L. Y means 1. Eta means minus 1. Eta means minus 1. So if it is minus 1, you can bring that into the denominator. And rearrange this equation like this. R to the power 4 delta P over L eta. Okay. Everyone, I need your response. Do you understand this one? I know you can understand my physics part of this equation, this question. There is no doubt. You can understand that one. Other thing is mathematics. Okay. Good. Others? So this equation is called as Poiseuille's equations. Poiseuille's equation. Okay. Okay, once you complete writing, please do question number 10. Question number 10. 10th question එක කරාද? හොඳයි මේ 10th question එකේ අතන මට ඕනනේ මෙතන density කියන දාගෙන යන්නේ මේ depth කියලා දාන්න. ඒක density වෙලා තියෙන කමන්න density හදන්න අපි depth කියලා හදමු. හරි. Okay. In 10th question, the speed of water wave V is proportional to its wavelength lambda and density of water D and the gravitational acceleration D. Actually, there's a small printing mistake. I wanted to give you the depth. Suppose if there's a water wave, suppose if there's a water wave in C, that D means the depth to the seabed. Okay, this is the water level. Okay. අපිට ඔන්න try කරන්න පුළුවන් density එක දාගෙන හදලා බලන්න පුළුවන් try කරන්න පුළුවන්. වඩා හොඳයි. ඔක depth කියලා දාගන්න එක. depth. Okay. මොකද මම ඔය equation එක දුන්නේ මට ඊළඟ section එකට පොඩ්ඩක් enter වෙන්න ඕන නිසා. So I think it is better to write depth. So if there's a water wave, if there's a water wave in water, the speed of water wave V depends on D, depth to the seabed or water riverbed. Then lambda means wavelength. Then G, gravitational acceleration. Wavelength. What is the meaning of wavelength? Wavelength. I think you have done this one in your orals, no? Wavelength. Wavelength kala dethi in orals. Wavelength. Suppose there's a wave, something like this. This is a wave. If this is a wave, wavelength is the distance between these 2 points. Normally we call this as a full wave. This is a full wave. Normally we call this as a complete or full wave. So there are two complete waves. So lambda is distance between these 2 points. Wavelength. Then take ඇති. ඒ කියන්නේ lambda කියන්නේ මොකද්ද කියන්නේ දැන් take ඇති මොකද definitions එක මම පස්සේ කියලා දෙන්න. lambda කියන්නේ මේ length එක කියලා තියෙනවා. ඒ නිසා lambda කියන්නේ length එකක්. එච්චර. So lambda is a length පුතා. Lambda is a length. So V depends on depth, wavelength, and gravitational acceleration. Definitely, you will find some problematic area in this question. Okay. Try to do this. Try to do this, and let me know what is the problem. Let me know what is the problem. මම එකත් කිව්වා මෙතන ප්‍රොබ්ලම් එකක් තියෙනවා. මට ඕනේ මේ ප්‍රොබ්ලම් එක මොකක්ද කියලා බලන්න. ඔයගොල්ලෝ අඳුර ගත්තද කියලා බලන්න. So everyone try to do this and let me know if there is any question. Okay, shall we do that? Shall we do that? Or if you need any further time, please let me know. Okay. Shall I do that? Okay. According to given data, the velocity of wave depends on depth, lambda, and g. Depth, lambda, and g. So I can assume the velocity of wave directly proportional to some power of d. That is my first assumption. The second assumption is the velocity of wave directly proportional to some power of lambda, and velocity of wave directly proportional to some power of g. Those are my assumptions. From this assumption, I can build a combined relationship. What is that? V is directly proportional to product of these two, d to the power x, lambda to the power y, g to the power z. That is my combined one. Then I can convert that relationship into an equation using proportionality constant. G to the power z. Now I have to find x, y, and z. How to do that, Puta? How to do that? As this is an equation, I have to equate dimensions of LHS and RHS. LHS and RHS. As this is an equation, dimension of LHS should be equal to dimension of RHS. So dimension of V should be equal to the dimension of D to the power X, dimension of lambda to the power Y, dimension of G to the power Z. G to the power Z. Now I can substitute dimension of each and every physical quantity. Velocity, dimension of velocity, I know dimension of velocity is equal LT minus 1, LT minus 1, LT minus 1. Then depth, depth is a length, depth is a length. So L to the power X. Lambda, lambda is wavelength, wavelength is also a length, is also a length. So dimension of lambda is L. Then G, G is acceleration, G is acceleration. So dimension of that one LT minus 2 into Z. So LT minus 1, LT minus 1 is equal L to the power X, Y, and Z. To the power X, Y plus Z. Then T to the power minus 2 is it. T to the power minus 2 is it. What will happen now? Now I can equate these two. Now I can equate powers of same bases. So if I equate power of L, in LHS it is equal to 1 is equal X plus Y plus Z. Then power of T, if I equate power of T, this one is minus 1. Here 2 is A. 2 is A. Okay. Now, what is the problem now? Can anyone tell me? Is there any problem? Can anyone tell me? මොකක්ද මෙතන තියෙන problem එක? මෙතනින් එහාට මම කොහොමද හදන්නේ? Can anyone tell me? From that I can determine the value of Z. I can determine the value of Z. After that, what will happen? Can anyone tell me? Yeah, Z is half. Z is half. After that, how to determine X and Y? How to determine X and Y? I think you have done simultaneous equation in all else, no? Yes, we will have to create two equations. So can we create two equations with X and Y? Can we create? That's the problem, Bhuta. Yes, your answer is correct. If you want to find X and Y, X and Y, there should be two equations. Okay. Other thing is in this equation, actually there are three unknown factors. What are those? X, Y, and Z. X, Y, and Z are the unknown factors here. If I want to find three unknown factors, so how many simultaneous equations should be there? If I want to find three unknown factors, how many simultaneous equations should be there? How many? At least? If I want to find three unknown factors, there should be three different simultaneous equations. three different equations. Okay. In this case, I have only two equations to find three unknown factors. In this case, I have only two equations to find three unknown factors. Can I do that now? Can I solve this equation? No, Buddha. I cannot do that. I can find one. I can find one using this equation. Only said I cannot determine x, y, and y because I don't have enough equations to determine x and y. Okay. That's why I wanted to change this as depth, because if there's depth, I cannot solve this equation. I cannot solve this equation because I don't have enough number of simultaneous equations. This is a limitation of this analysis. Okay, Buddha. This is the limitation. This is some limitation. This is a limitation of this analysis. Okay, if you want to build the equation, if you want to determine an equation between some given physical quantities, then you have to assume some assumption, you have to assume some unknown factors there. To find these unknown factors, then you should have enough number of simultaneous equations. Otherwise, you cannot solve this question. Okay, so this is a limitation of this analysis. What is the limitation? We should have enough data. We should have enough data to evaluate unknown factors. Otherwise, we cannot evaluate a relationship between the given physical quantities. Do you understand? Everyone? I not actually I want to hear a response. Do you understand, Puta? Okay, others? Because my next topic is limitation of this analysis. That's why I give this question as the final question of this session. This is a limitation of this analysis, Puta, because if I want to analysis, if I want to find an equation, if I want to build a relationship, then I should have enough number of simultaneous equations to solve unknown factors. If you assume two unknown factors, at least you should have two simultaneous equations. Two different equations. Okay, two different equations mean. Suppose there are two equations, something like this. X plus y is 2, 2x plus 2y is 4. Are they two different equations? Although there are two equations, both the equations are same. No? X plus y is 2. So if you multiply both sides by 2, 2x plus 2y is equal to 4. So this is the same equation, not two different equations. So if you want to solve two unknown factors, then you should have two different simultaneous equations. Okay. If you want to solve three unknown factors, at least you should have three different equations. So you cannot solve three unknown factors with two different equations. You cannot solve them. Okay, write this one up to this level. Meanwhile, please let me know if you have any doubt. Please let me know, Huta. I will explain that one. Please write this up this level. I want to give some note. Okay, right under this. Have you finished writing? Have you finished writing? Please let me know. Okay. Okay. Write down this one. There are three unknown terms. There are three unknown terms in our assumption. There are three unknown terms in our assumption. But we can build only two different simultaneous equations. But we can build only two different simultaneous equations. Therefore, we cannot solve this question beyond this level. We cannot solve this question beyond this level. This is a limitation of this analysis. This is a limitation of this analysis. Okay. Write down the next topic. Next topic is limitations of above analysis. Limitations of above analysis. Now we are going to discuss about limitations of analysis in determining of equations. When we are determining equation, when we are building an equation, we use dimensional analysis method. Now we are going to discuss about limitations of that application. Limitation of that application. Okay. Write down the topic: limitations of above analysis. Limitations of above analysis. I think we have discussed about some limitations. What are those limitations, Puta? Tell me. It is better to participate with the class. Everyone, please tell me. What are the limitations? I think we have discussed about some limitations. What are those limitations? What are those limitations? First thing, we couldn't find K value, no? What is K value? Proportionality constant, no? The first difficulty we faced here, we couldn't find K value using this analysis. Actually, if we want to build an equation, the K value should be given. Otherwise, we cannot build the equation. So, the first limitation is we cannot determine the value of the proportionality constant. We cannot do that. It should be given. Otherwise, we cannot apply this method. Okay. Other thing is we cannot determine the dimension of proportionality constant. So suppose there is a limit, there is a dimension of the proportionality constant. We cannot find one. So if there is a value, or dimension for the proportionality constant, it should be given. Otherwise, we cannot apply this method. Okay, that is the first limitation. That is the first difficulty we face during this method. Okay, write down first one. First one, the value of K, the value of K, the value of K, the value of K within the brackets, proportionality constant. Proportionality constant. Proportionality constant cannot be determined using this method, using this method, using this method. Therefore, 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 the value of k, the value of k, the value of k should be given, should be given should be given in order to apply this method, in order to apply this method. The second one, the second difficulty, second limitation. Write down that one. If the proportional constant, if the proportional constant, if the proportional constant has a dimension, has a dimension, has a dimension it should be given, it should be given, it should be given to determine the equation, to determine the equation, to determine the equation. Okay, suppose this one. Okay, look at the board. And in this, when we assume the assume equation, suppose we have assumed this kind of equation: y is equal k to the power k into r to the power a, p to the power b, q to the power C. Something like this. We have assumed this kind of equation. Okay. Actually, if we want to find A, B, and C, we have to equate the power of M, power of L, and power of T. Power of M, power of L, and power of T. Okay. Normally, according to our A-level syllabus, M, L, and T are the only dimensions we know. Okay. Otherwise, we should be given the extra dimension. Until that, the only dimensions we have M, L, and T. Only dimensions we have M, L, and T. So, if we want to build simultaneous equations, we can build up to maximum 3 number of simultaneous equations by comparing the power of M, by comparing power of L, and by comparing power of T. Okay. So equating power of each and every dimensions, I can build maximum up to 3 number of simultaneous equations. 3 number of simultaneous equations. So this is the maximum number of simultaneous equation that I can build. Okay. Then there's another limitation. Then I can find only up to 3 numbers, 3 unknown factors here. More than that, beyond that, I cannot find. Okay. So the maximum unknown factors that I can find through this method is 3. Okay. Otherwise, beyond that, I cannot find anything, because the only dimensions I know, according to our A-level syllabus, the dimensions I have only these 3, M, L, and T, Okay. Otherwise, it should be noticed. Okay. So if it is not a different question, those are the only 3 dimensions that we have. Okay. So using these 3 dimensions, we can build up to maximum 3 different equations. So the maximum number of unknown factors that can be evaluated using this method is 3. Okay. So if I evaluate 3 unknown factors, there are 3 different physical quantities. Here, there is another physical quantity. No, here there's another physical quantity. Altogether 4 physical quantities. Okay. That means using this method, I can combine maximum up to 4 physical quantities. Beyond that, I cannot build an equation. Do you understand, everyone? Say another. Oh, I need your response.
Understood, sir.
Very good. Thank you. So in this method, using this method, we can build the equation maximum up to 4 different physical quantities. Okay. Write down that one. Number 3. The maximum number of physical quantities. that can be combined through this method through this method R4 okay. Suppose we are given, we have assumed this kind of equation. Suppose we have assumed this kind of equation. In this equation, there are three unknown factors. There are three unknown terms. So we have to equate the power of M, L, and T only. M, L, and T only. M, L, and T only. That means we can build up to 3 simultaneous equations. So that means therefore we can build 3 simultaneous equation therefore we can build maximum. So therefore we can build maximum 3 simultaneous equation. Okay. You can write this under the third point. You can write this under the third point. Y is equal K into P to the power A, Q into P to the power B, Q to the power B, R to the power C. We have to equate the powers of MLT only, ML and T only. Therefore, we can build maximum 3 simultaneous equations. Therefore, we can combine maximum 4 physical quantities, using this method.
Sir, can you repeat it again?
We can build 3 minutes. Therefore, we can combine maximum 4 physical quantities. We can combine maximum 4 physical quantities using this method. Fourth limitation. Fourth one. We have discussed that one. Okay. Sorry, body connection failure. Okay. Fourth one. The number of unknown terms. And the number of simultaneous equations. The number of unknown terms and the number of simultaneous equations should be equal. Otherwise, all the unknown terms may not be evaluated. Okay. Everyone. Do you have any question up to now? Because now we have complete all the applications of dimensional analysis. Now we have complete that part. Do you have any questions up to now? The first application is evaluating the accuracy of an equation.